So welcome to all of you. So we have seen the theoretical part of the limit. Now we'll see the application of that theorems and we will solve some problems on the limit. Okay. So this is the first problem is that so we'll say this is let L is equal to limit x tends to 2 x square plus 1 upon x cube minus 4. Okay. So now how to evaluate such a limit now? So if this is 0 by 0 form then we have to take a we have to think on it now. So if it is not 0 by 0 form, or if your numerator is not 0 or denominator is not 0, directly you can put the values of the x as it is. Now see what happens if you put x is at the numerator. So see, this is what 2 square plus 1, so that is what 4 plus 1 is a 5, so that means your denominator is not 0, so you can put x is equal to 2 directly at the numerator and denominator. So the value of this limit is what? 2 cube minus 4. So this is what? 4 plus 1 upon 8 minus 4. So this is what? 5 upon 4. This is your answer. Okay. So it's the second one. We'll let n is equal to limit x tends to 2. X tends to 2. This is x cube plus 1. X square minus 1. There is no denominator. There is no denominator. So directly you can put the value of x at the here. So this is what? 2 cube plus 1 into 2 square minus 1. So this is 8 plus 1 is 9. And this is what? 4 minus 1 is 3. So this is what? 27. Next, third problem. If it is not 0 by 0 form, directly you can put x is equal to, or whatever it is given, x is equal to c in the function. Okay. So let n is equal to limit x tends to 2, all are x tends to 2. Okay. So x square minus 4 upon 3x minus 6. Now see here, if you put x is equal to 2 in the numerator, your numerator is 0. So see what happened at the denominator, your denominator is also 0. So if it is 0 by 0 form, you have to think a little bit. So that means what? You have to remove x minus 2 from the numerator and denominator. You have to remove the factor x minus 2 from the numerator and denominator. Note that x tends to 2 does not imply that x is equal to 2. So x not equal to 2, so therefore you can cancel x minus 2, x minus 2. Okay. So this is what? Limit x tends to 2. This is what? X minus 2, x plus 2. You can factorize this. You can take 3 common here. So you get this. Okay. So now here x minus 2, you can cancel this because your x minus 2 is not 0, because x tends to 2 does not imply that x is equal. That means x tends to 2 means x is in the deleted neighborhood of 2. That means x is not equal to 2. So therefore you can cancel this 2 now. This is limit x tends to 2, x plus 2 upon 3. So this is what? 2 plus 2 upon 3. So this is what? 4 by 3. Okay. So very simple. Okay. Now we'll go to fourth one. Limit n is equal to, okay. Let n is equal to, this is not compulsory to write n is equal to, but we will write this. Let n is equal to limit x tends to 1, x tends to 1, x raised to cube plus 4x minus 3 upon x square minus 12. Now see, if you put x is equal to 1 at the denominator, your denominator is not 0, whatever the numerator may be. So your denominator is not 0, so directly you can put x is equal to 1 here. So this is what? 1 plus 4 minus 3 upon 1 minus 12. Directly we can calculate the powers. Powers are integral terms also. So this is 5 minus 3. 5 minus 3 is 2. 2 upon minus 11. So this is minus 2 by 11. Okay. So this is the we have solved the 4 problems here. Okay. So we'll go to the next problem. Next, solution of the fifth one. Okay. So let limit x tends to 1. Let n is equal to limit x tends to 1, x cube minus 1 upon x square minus 1. So this is limit x tends to 1. So now if you put x is equal to 1 at the denominator, your denominator is 0. If you put x is equal to 1 at the numerator, numerator is also 0. That means what here? X minus 1 is the factor of the numerator and denominator. So you have to remove that. Okay. So we'll factorize this. This is what? X minus 1 x square plus x plus 1 upon x minus 1 x plus 1. So now you can remove the factor x is equal to 1. X tends to 1 means x not equal to 1. X is in the deleted neighborhood of 1. So therefore x minus 1 is not equal to 0. Therefore you can cancel x minus 1. So this is what? Limit x tends to 1 x square plus x plus 1 upon x plus 1. Okay. So now put x is equal to 1 and the denominator. See that denominator is not 0. Whatever the numerator may be. So directly you can put the value of x here. So this is 1. 1 plus 1. So this is what? 3 by 2. 3 by 2. Okay. So we'll go to the next one. Okay. Solution of the sixth one. Okay. So let L is equal to limit x tends to 4. 4 minus root of x plus 12 upon x minus 4. Now see, if you put x is equal to 4 here, your denominator is 0. What happened for the numerator? So 4 plus 12 is 16 and root of 16 is 4. 4 minus 4 is 0. So this is 0 by 0 form. So this is what? 0 by 0 form. You may write here, this is 0 by 0 form. So if it is 0 by 0 form, then you have to take a x minus 4 factor from the common from the numerator and denominator and you have to remove it. But see here the root is there, right? So if the root is there, then you are familiar with the rationalizing. So your root is at the numerator. So what we will do? We will rationalize the numerator. We will rationalize the numerator. To rationalize the numerator means what? You have to multiply and divide by the conjugate of the numerator. So conjugate means what? If there is a plus b, the conjugate of a plus b is a minus b, and conjugate of a minus b is a plus b. So you have to multiply and divide by the conjugate. If you multiply and divide by the same number, then your whatever the quantity will be as it is. You are dividing and multiplying simultaneously. At a time you are dividing the multiply and dividing. That means your function will be as it is. So only what here? The picture change. So limit x tends to 4. We will rationalize the numerator now. 4 minus root of x plus 12 upon x minus 4 into. So this is what? 4 plus root of x plus 12 upon 4 plus root of x plus 12. Okay. Now we'll multiply. Limit x tends to 4. Limit x tends to 4. So you have to multiply numerator. So this is a minus b, a plus b, and you know that a plus b, a minus b is nothing but a square minus b square. The square of the first one minus the square of the second one. The square of first one is 16 minus the square of second one is what? Just root is removed only. Okay. So this is what? A square minus b square. Then you have to write this as it is. So this is what? 4 plus. You have to write in bracket now. Okay. So this is equal to. Now we will simplify this. This is limit x tends to 4. So if you remove this, what you get? This is 16 minus x minus 12. So that is 4 minus x. This is 4 minus x. So this is what? X minus 4 into 4 plus root of x plus 12. X plus 12. Right? X plus 12. So this is equal to, I will write here, this is equal to limit x tends to 4. Now this is 4 minus x, that means minus of x minus 4, x minus 4. So x minus 4 get cancelled. So this minus 1 remains here. So this is what? Oh, no need the bracket, x plus 12. No need the bracket, right? So now you can put x is equal to 4 here. So what we get? Minus 1, 4 plus 4. This is minus 1 upon 8. This is what? 4 plus 12 is a 16. Root of 16 is 4. So this is minus 1 upon 4 plus 4 is minus 1 by 8. So the required answer for this one is minus 1 by 8. Okay. Now we'll take the next one. Solution of this. Okay. Let L is equal to limit x tends to 0. root 6 minus root of 5h square plus 11h plus 6. You are familiar with such type of the problem. So if you put h is equal to 0, this is h, not x. This is what? This is not x now. This is h now. Okay? This is h. We will correct the problem. So if x is there, x tends to 0 in the exam, right? So the value of this limit will be this function now. Because what, there is no x. If there is limit x tends to 0 of this, then just write this answer, root 6 minus this, and this will be as it is. So now we will correct the problem here. Limit x tends to 0 will take. Okay. So if there is x tends to 0, then you don't do value of the answer is what? The root of 6. Your answer will be root 6 minus this will be as it is. If there is a x tends to 0. But we will correct this. So we will take h tends to 0. Okay. So there is a printing mistake. So now again see, your denominator is 0. What happened to your numerator? Root 6 minus root 6. Your numerator is also 0. So this is 0 by 0 form. Okay. So this is 0 by 0 form. So now here what? Here also this problem is 0 by 0 form. This problem was also for 0 by 0 form. Okay. So now if it is a 0 by 0 form, we have to think a little bit. Okay. So that means what? We have to think how to solve that problem. So if it is not 0 by 0 form, don't think anything. Just put x is equal to, replace x is equal to whatever given x tends to this. Okay. Just replace x as this one. Okay. So if x tends to c, just replace x as c now here. Okay. So if it is not 0 by 0 form, then we don't have to take attention. Okay. Okay. Now we have h tends to 0. That means what? We have to take h minus 0 means h common from the numerator and denominator. We don't have attention of the denominator. Only have attention of the numerator because there is a root. So if root is there, then what we have to do? This is a very useful method. Is that what? The rationalize the numerator. So rationalizing means what? Multiply and divide by the conjugate of the numerator. We are rationalizing here numerator. If it is at the denominator, then we have to rationalize the denominator. Whatever this one. This may happen that h upon this one. So that means what? We have to rationalize the denominator. Okay. So we will rationalize the numerator now here. So limit h tends to 0, root 6 minus root of 5h square plus 11h plus 6 upon h into, we have to multiply and divide by the conjugate of this one, plus root of 5h square plus 11h plus 6 upon root 6 plus root of 5h square plus 11h plus 6. Now we have to multiply numerator, denominator. Okay. So we multiply this. Limit h tends to 0. Now this is a minus b and this is a plus b. A minus b into a plus b, x square minus b square. The square of the first one is 6 minus the square of the second one is what? Just we have to remove the root now. Plus 6 upon h into, I have to write this in bracket. Okay. So root 6 plus root of 5h square plus 11h plus 6. Okay. Now if you simplify this, so what happened? So now this is 6. So this is what? Minus of, this is limit. Okay. Limit h tends to 0. Limit h tends to 0 minus 5h square minus 11h upon h into root of 6 plus root of 5h square plus 11h plus 6. Now see here, you can take h common. So you h, this term contains h, so you can remove the h now. So this is what? Limit h tends to 0. So this is what? Minus 5h, oh not plus now, this is minus 11 upon, no need now here bracket, root of 5h square plus 11h plus 6. Okay. Now see here, denominator there is a plus sign, all are positive. So directly you can put h is equal to 0. So if you put h is equal to 0, then this is minus 11 root 6 plus root 6. So this is minus 11 upon 2 root 6. This is the required answer. Okay. So now we'll go for the second one now. Next, so this is what? Solution of this one. So let L is equal to limit x tends to 2, 1 upon x plus 1 minus 1 upon twice x. Now see here, both the denominators are not equal to 0. Both the denominators are not equal to 0. So what we do? So we put directly x is equal to 2 here. So this is what then 1 upon 3 minus 1 upon 4. 1 upon 3 minus 1 upon 4. So this is what 4 minus 3 upon 12. So this is 1 by 12. Okay. So this is very simple. Okay. Now we will solve the last example now. This is the last one. So solution, let L is equal to this. Okay. So now what happened? If you put x is equal to 0, see denominator is 0 now. What happens? The numerator is also 0. So we have to rationalize this. So L is equal to limit x tends to 0. You have to rationalize the numerator. 1 plus twice x plus root of minus root of. Okay. So we have to multiply with the conjugate, that will do the upon. I will take x common here. So this is what? X plus 2. I will take x common here. And I have to multiply and divide by the conjugate of the numerator now. Minus 1 plus 3x upon root of 1 plus twice x minus, here what minus, so there should be the plus now. 1 plus 3x. Okay. Now we will multiply this. This is what? Limit x tends to 0. This is what? 1 plus twice x minus 1 plus 3x upon x into x plus 2 into root of 1 plus twice x plus root of 1 plus 3x. You have to take the care here of the bracket now. So if you simplify this, what we get? Limit x tends to 0. Limit x tends to 0. If you simplify that, 1 get cancelled and this is minus x now. This is minus x upon x into x plus 2 into root of 1 plus twice x plus 1 plus 3x. 1 plus 3x. The bracket complete now here. Okay. So now your x and get cancelled. That is our aim. You have to remove the x minus 0. That means x from the numerator and denominator. See, the denominator there is x, numerator there is x. You have to cancel this because x tends to 0 means x not equal to 0. So this is what then? Limit x tends to 0 minus 1 upon x plus